let's take a look at rational versus irrational numbers. Now, first of all, the term rational and irrational simply is a classification, just like odd and even. There are odd numbers, there are even numbers. Same applies for rational, irrational. It's just a name classifying certain numbers fall here, certain numbers fall here. So let's take a look at easy ways to identify, is it rational, is it irrational? The same way we would, is it odd, is it even? First of all, rational numbers by definition is any number that can be written as an integer over top an integer. That's the definition of it. So what does it look like? It looks like any number you can imagine that can be written as an integer, positive, negative, over a positive, negative. So for instance, 2 over 3, that's rational. Why? Because it fits the definition. 7 is rational. Can you tell me why 7 is rational? Can it be written as an integer over an integer? Yeah, it can be written as 7 over 1. So any fraction, first of all, fits. Any fraction is automatically rational. Any whole number is automatically rational. Any decimal that terminates, a terminating decimal, one that ends. It means it doesn't repeat, it doesn't keep going, we don't put a bar over top of any of the numbers. Terminating decimal is a rational number. Now why? Can 3.1 be written as an integer over an integer? It can. Because we know that 3.1 is the same as 3 and 1/10, and I can make that mixed number improper. 10 times 3 is 30 plus 1, that is 31 over 10. Check. There is one other type that counts as rational. We did fractions, check. We did whole number, check. We did decimal that terminates, check. The other one, let me clean this up. The other is a repeating decimal. All right, and I'll show you why that works in a second. But repeating decimals also works because this can also fit into an integer over an integer. How do you say? Well, do you know what 0.3 repeating is equal to as a fraction? It's the same thing as 1/3. 1/3 is an integer over an integer, so that's irrational. What about 0.6 repeating? 0.6 repeating is 2/3. What about 0.4 repeating? It is 4 over 9, I believe. And basically any other. What about 0.632 repeating? If I know this right, that's 632 over 999. So it'll work. Any repeating decimal counts as a rational number. So any fraction, automatically rational. Any whole number, automatically rational. Any decimal that terminates, automatically rational. Any decimal that repeats, has a bar over it, repeating pattern, also rational. So now you're saying, okay, with all of this, what's left? What numbers are irrational? What numbers don't count? Things that don't count, things that are irrational. Irrational numbers are decimals, that don't end, and don't repeat. Those are irrational numbers. It's only one of them, and now there's an infinite amount of them, but it's simply decimals that don't end and don't repeat. A classic one is pi. 3.1427865. I don't know if these are right, I'm just making guesses. But notice there is no repeating pattern. It does not end, it keeps going and going and going and going. The square root of most numbers also count as irrational. Try on your calculator the square root of 2. And the square root of 2 is 1.41 something 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 something. Those are irrational numbers. So simply ask yourself, of my 4 types, is it a fraction? Is it a whole number? Is it a decimal that terminates, which means it ends? Is it a decimal that repeats? If it's any of those 4, it's a rational number.